Hello students, welcome to the virtual world of Georgia Tech's CS3510 for the fall of 2020. I'm Jake Abernethy and I'm going to be your virtual professor this semester, so you better get used to this voice for at least the next 6 or 7 weeks. So I did an undergraduate degree in mathematics at MIT. I got a PhD in computer science at UC Berkeley. And I can tell you I didn't really expect that after all that time I would suddenly turn into an aspiring YouTube star. But here we are. Look how cute this dog is. Hey there, don't forget to smash that like button. Okay, we should get serious now. Let's just talk about these lecture videos and how you should use them. Each video will describe one piece of content for the course and will prepare you for the live sessions. In live sessions, we're going to work on problems. Let's just do one bit of content that isn't actually required, but will give you a sense of what we'll be describing in these videos. So have you ever thought about the question of how many prime numbers there are? You may have heard that there's an infinite number of primes, but how do you know that, right? We have, so let's just list out some of the prime numbers. We have 2, 3, 5, 7, 11, right? Now how do we know that these numbers are prime, right? Well, let's say we know that 23 is prime because 23 isn't divisible by 19, 17, 13, 11, 7, 5, 3, or 2, right? That's how you check if a number is prime. But how do we know that this list doesn't just stop somewhere? Maybe this list goes on for a little while and then suddenly stops. Why do we know that there's an infinite number of primes? All right, now we're actually going to prove that there are an infinite number of primes. Okay, so now we're going to use proof by contradiction to establish this claim that there are infinitely primes. So to use proof by contradiction, we're going to assume towards a contradiction that actually there are only n primes, capital N many primes, and we can just list them out. We have P1 is the first prime, that would probably be 2, P2 would be 3, P3 would be 5, and so forth, right? And then there's just some largest prime, P sub capital N, right? And this P sub n is the largest prime number. And what does it mean to be the largest prime number? It means that any integer k which is bigger than Pn is not going to be a prime number, right? That's what it means to be the largest prime. Anything larger is not going to be a prime number. So I've listed out all of the prime numbers, P1 through Pn. Now let's just imagine taking an even larger number than all of these, which is q, right? The number q is going to be the product of all of these prime numbers, P1 times P2 times ... times all the way up to Pn. Plus 1. You add 1 to this large product. You have this large product here, and you simply add 1 to that number. That's our number q. Q is an interesting number, and let's think about why that's an interesting number. It's important to note that this number q is not divisible by P1 or P2 or P3 or all the way up to Pn, right? It can't be divisible by any of these numbers because it's not divisible by P1 because it's P1 times some other integer plus 1. If you're P1 times some other integer plus 1, you're not divisible by P1, right? You would have a remainder of 1 when you tried to divide by P1. Similarly, if you tried to divide Q by P2, you would have a remainder of 1. So it's not divisible by P2, and so forth. It's not divisible by any of these primes, P1 through Pn, right? But if it's not divisible by P1 through Pn, by any of these prime numbers, then it has to be prime itself. That's what we mean by a prime number. A number that isn't divisible by any of the smaller primes is then also a prime number. So we've now concluded that q is also a prime number. So what we've done here is we've found a contradiction. We constructed this number q. We noticed that q is both larger than all of the smaller primes, P1 through Pn. It's not divisible by any of them, and therefore it has to be a prime number. This is a contradiction, right? We assumed that P sub n was the largest prime number, and suddenly we found a prime number which is larger than it. The only thing we can conclude here is that our assumption that there are finitely many primes is wrong. And therefore we can conclude that there must be an infinite number of primes. So there we have it. Okay, so that was just an example of one piece of content that we might explore in these videos. What you should know is that watching these videos is required before you come to the live session. Let me show you how you can find which videos are required for the course for every day. You can find the list of videos that you're required to watch before each live session here on the course webpage. You'll notice, for example, for Thursday's lecture, you're going to have two lecture videos to watch on big O notation and computing Fibonacci. We'll also include on the webpage the link to the live session. So you can find all of the content that you're required to process before coming to the live session right here on the course website. For every day, there'll also be some reading, not very long, from the textbook. The textbook is called Algorithms by Dasgupta, Papadimitriou, and Vazirani. I'll just mention, by the way, that Christos Papadimitriou was actually on my thesis committee in grad school. and I know Sanjoy Dasgupta quite well as Umesh Vazirani. Just keep in mind that watching the videos is important, and in fact, we're going to quiz you on whether you watched them. So we might ask you a question like about some of the content from the lecture. We also might ask you something silly like, what was the word of the day? You might hear me say in these videos something like, the word of the day is hippopotamus. And now you should note that hippopotamus might be something you'll be quizzed on. So I suggest you write that down. All right, everyone. So we're looking forward to having you in the course this semester, and we hope that you guys all have as much fun as I have been having making these YouTube videos for you guys. Let's have a great semester. Don't forget to smash that like button.